Welcome to The Explainer. Today, we are going to tackle something called Object-Oriented Programming, or OOP for short. You've probably heard of it. It's this really powerful way to bring some structure, some real-world logic right into your code. All right, so here's what we're going to cover. First, we'll look at the problem that OOP was invented to fix. Then we'll walk through the big ideas one by one, and you'll see how it really does take programming from, messy to manageable. Okay, first up, to really get why OOP is such a big deal, you gotta understand the chaos it was meant to solve. You've probably seen it, maybe even written it. Code that's just a tangled mess. It's so unstructured, it's almost impossible to follow. Well, programmers have a perfect name for this: spaghetti code. It's exactly what it sounds like, a giant, jumbled plate of code where everything is all mixed up. And this right here, this is a feeling every developer knows. Your code works today, right? But then you have to come back 6 months later to fix something, and oh man, it's a total nightmare. And trying to get someone else on your team to understand it, yeah, good luck with that. So, how do we fix this mess? Well, the answer isn't just some new tool or a quick trick. It's a whole new way of thinking, a fundamental shift in how we even approach writing code. This is where OOP comes in. It gives us a set of rules, a standard approach that puts everything into, well, objects. So instead of just writing a long list of instructions, you start thinking of your program as a little world filled with things that interact with each other. And trust me, that mindset is the absolute key to building big, complex apps that don't just fall apart. And here's the core idea. Every single object in your code has two things. First, it has properties. That's the stuff it knows about itself, like its name or its color. And second, it has behaviors. That's the stuff it can do, like move or jump or calculate something. We usually call those behaviors methods. Okay, so if we're going to start making all these cool objects, we need a plan first, right? Kind of like a template that says what they should look like and what they can do. This quote just nails it. A class is a blueprint. In OOP, that master plan is what we call a class, and it's super important to remember. The class isn't the actual house. It's just the drawing, the design we use to build the house. Look at how this analogy lines up. A blueprint for a house defines its properties, doors, windows, rooms. A class does the same for our object. It might have X and Y coordinates or a name. A blueprint shows actions, like opening a door, and a class, it defines methods, which are just the actions our object can do. And the great thing is, in a language like TypeScript, it's super straightforward. You just use the keyword class to start laying out this blueprint for all your future objects. All right, we've got our blueprint. But let's be real. If you're building a whole neighborhood, you don't want every single house to be an exact copy. You need a way to make each one a little different. So that brings up a really important question, right? If we're just stamping out objects from the same blueprint, how on earth do we give them their own unique details right from the start? The answer is something called a constructor. It's a special function. Think of it like this. It's the setup instructions that run the instant a new object is created. It's the perfect moment to hand it some custom info to make it unique. And you can see the difference right here. Without a constructor, every new point we make is identical, same coordinates every time. But with a constructor, we can feed it different values when we create it. One point can be at 2010, another at 515. That's what makes our code flexible and powerful. Okay, now we're getting to one of my favorite parts of OOP. It's maybe one of the most powerful ideas in all of programming, period. And it's all about one simple concept. Don't start from scratch. Build on what you've already got. It's called inheritance, and it is all about reusing your code. The idea is simple. You make a general parent class that has all the common stuff. Then you can make more specific child classes that get all of that for free. They just inherit it. I mean, this saves so much time. It's how you stop reinventing the wheel over and over again. Honestly, the best way to think about it is with biology. You could have a parent class called animal, right? And it would have properties and methods that all animals share, like a name or a move method. Then you can have child classes, like snake and horse. They automatically get the name and the ability to move, but then they can add their own special stuff. The snake class might add a slithering method, and the horse adds a galloping method. See? You build on what's already there. So how do you actually make that link in the code? It's literally one word: extends. That keyword is what tells the program, hey, this new snake class, it gets everything the animal class has. Okay, one more little detail here. If the child class needs its own special setup, its own constructor, you have to make sure the parent setup runs first. And you do that by calling super. It's like saying, hey, run the parent's constructor first to get all that stuff ready. Then I'll do my own special setup. So let's just recap the big takeaways, right? OOP is how we get away from that messy spaghetti code. We use classes as our blueprints. We use constructors to make each object unique when we create it. And we use inheritance to reuse code and stop repeating ourselves. That's the core toolkit. At the end of the day, it's really about changing how you see code. You're not just writing a list of instructions anymore. You're actually building a little world of objects that talk to each other. And that shift in perspective, that's what lets huge teams build massive software that can actually grow and change without breaking. And that's our look at the basics of object-oriented programming. So I'll leave you with this question to think about. How might organizing your code like real-world objects change the way you solve problems? Some that you on. Thanks for joining us.